Hello everyone, my name is Li Hao. So today we're going to do Advent of Code 2020. So Advent of Code is a series of programming challenges that is on the Advent calendar. And on each day on the calendar, you have one programming challenge. And in it, there's two parts of it. So solving each of the parts give you one gold star. And the aim of this is to try to get 50 gold stars. Are you up to the challenge? So today we're going to do day 13, which means that if you're first time watching this video, you are missing out a lot, which if you want to catch up from day 0 to day 1 to day 12, click here. Here's the link. And that's all. We are going to try day 12. Day 13, okay? Wake up. So, okay. Let's go to the calendar. And let's look at day 13. So day 13, Shuttle Search. Your ferry can make it safely to a nearby port, but it won't get much further. When you call to book another ship, you discover that no ship embarked from the ports that you vacation island. So you need to get from the ports to the nearest airports. Well, fortunately, a shuttle bus service is available to bring you from the seaports to the airports. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on timestamp that measures the number of minutes since a fixed reference points in the past. So at timestamp 0, all the bus simultaneously departed from the seaports. And after that, each bus travels to the airport, the various other locations, and finally returns to the seaport again and repeats its journey forever. The time this loop takes a particular bus is also its ID number. Oh, okay. So the bus ID with 5 departs from 0, 5, 10, 15. So it's a multiple of 5. Right? The bus with ID 11 departs at a multiple of 11s, right? 0, 11, 23, 33. So you have there when the bus departs, you can write the bus to the airport. So a note consists of 2 lines. The first line is an estimate of the earliest timestamp you could depart on a bus. The second line lists the bus IDs that are in service according to a shuttle company. Entries that show X must be out of service. Okay, so you can ignore them. To save your time, once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will only be one exactly such a bus. So for example, suppose the following notes. Okay, so here's the earliest timestamp. So you reach at 939. And the bus service is 7, 13, 59, 31, and 19. Right, so this is when you arrive. So the nearest is 944, right, which is the bus 59. The earliest bus you can take is bus ID 59. It does depart until timestamp 944. So you wait for 5 minutes. So multiply 5 with the bus ID, which is for 59 times 5, which is 295. So once the ID, the earliest bus, multiply this number. Okay, so we need to find this number 295. Let's get the puzzle input. Okay, so let's save this. Input.txt. Let's move it to day 13. Let's code day 13. Okay, so let's take a look at. Okay, we don't have to look. So we don't have to look at inputs. I roughly know how it looks like. Okay, let's look at it again. Okay, day 13. First line is the earliest time you arrive, and then next line is the bus timing, right? So we're gonna read this file. Sorry, let's start read file sync. So content.split by new line. So you have 2 lines. So the first line is the earliest arrival. And second is the bus timings. Okay. So I'm gonna use a let because I'm gonna make it a number. Okay, and the bus timing, let's split by comma, right? And filter out things that are not an X. I believe it's a small caps X, okay? And with the rest, we're gonna map it as a number. Okay, bus timings. Okay, so we get the earliest time arrival and the bus timings. So we need to find which is the earliest bus that we can take. Well, if you take a look at here, right, in the example, close this. Actually, all the bus arrives at a multiple of, like, the bus 7 arrives at a multiple of 7, bus 13 arrives at a multiple of 13, right? So from here, 939, which is when you arrive, if you modulus like 7, which is okay, let me do this. Note, okay, so 939 modulus 7, you get 1, which means that you are one of the last bus that you are, bus 7 that just departs, right? Which also means that you are 7 minus 1 away from the next bus, which is 6, right? Which is over here. So same thing goes with bus 13, which is 939 modulus 13, which is 3. You miss it 3 timestamp with the last departed of the bus 13. So 13 minus 3 is like the next one comes in 10, right? So next one comes in 10, which is 949. So you can just keep doing this and probably will find that 939 minus 59 is 54. So 59 minus 54 is 5 timestamps later, which is the nearest, right? And which is this 5 minutes that you need to wait. So we can do this, we can use the modulus, and then we minus it off, and then probably we'll find the smallest number, and that will be the bus that we can take, the nearest bus that we can take to depart. So for const bus timing of bus timings, okay, we're gonna use this as minute to wait is the bus timings minus the earliest arrival modulus of bus timings. Okay, this is the number of minute to wait. So we're gonna keep 2 variable, which is the bus to take and also the minute to wait, the minimum minute to wait. So I'm gonna initialize this as a max number, something very big that we can something that is very big. So so that when we keep counting, like the first bus that you have will be definitely smaller than this number, right? So if minute to wait is less than the minimum, then minimum will assign to it, and the bus to take will be the bus timing. So the bus timing is the bus ID, it's the same thing. Okay, so the last thing we do is that we'll have minimum time to wait times the bus to take. Okay, I think that's it, and let's run this. Let's clear this, and let's run day 13 205. Do you think that's the right answer? Yay, that's the right answer. And let's move to part 2. Shuttle company running a contest. 1 gold coin for anyone can find the earliest timestamp, such that the first bus ID departs at the time at each subsequent listed bus ID departs at that subsequent minute. So such that anyone can find the earliest timestamp such that first bus ID departs at the time. Okay, so for example, and have this list of this. X means that there are no constraint on what bus ID must depart at that time. Looking for the earliest timestamp called T, such that bus ID departs at time T, 1 minute after time T, then requirement restrictions on departure at 2 minutes or 3 minutes after timestamps T. So you want a okay, 2 or 3. Okay, so no constraint for 2 or 3. Then this 59 must depart 4 minutes after timestamp T. Bus 31 must depart 6 minutes after T, and 19 should depart 7 minutes after timestamp T. Only bus departures that matter are the listed bus IDs that specific time offset. Okay. And then bus 7 will always also be departing with the bus. For example, in the list below, because bus ID 19 must depart 7 minutes after the timestamp, which bus ID 7 departs. So bus 7 will always departing with bus ID 9, okay, 7 minutes timestamp. Example, the timestamp which this occurs is, wow, this number. And the example above bus, okay, so here's an example. Okay, so we need to find this timestamp where 7 departs exactly at this time, right? And then the next 13 bus will, based on the position of in the timetable, they should be 1 minute after, and they should be 3 minutes after, and 5, and then so 1, 2, 3, 4, 4, and then 6, and then 7 minutes after. Right? So here is an example of the number. However, with so many bus IDs in your list, sure the actual timestamp will be larger than, wow, this is a huge number, right? So probably we need something, some mathematics or something that we can find this number, right? So let's see. So this number must be multiple of the first number. So multiple of 7 for this will be, right? This should be a multiple of 7. Right, bus 9 is also a multiple of 19. Wait, is it? No, it's not a multiple of 19. So it's a multiple of 19 plus 7. Right, so this, plus 12, because, so minus 12, and then this should be a multiple of 19, right? Minus 12 because it's over here, it's 7 apart, right? So should be 12 before the last departed, right? So this number is, it's gonna be, okay, so let's take a look at this. We can go through every multiples of 7, and yeah, we can go through every multiples of 7 and then see whether this number is mixed, fulfill this requirement. But still, let's see how many loops that probably will have to make. So I probably have to make another 100 over 1,000 of loops to actually find the number, the first number, right? And the number can be this huge. That means it takes even longer to actually find it. right? So it's the multiple of 7, and let's see, it's a multiple of 13. It's a 13 plus 12, right? Let me think about it. So actually I teleported to use Google while this is being cut in between. And I found out that this actually can be applied using something called a Chinese remainder theorem. Well, I'm not sure I want to bore you with the maths, but let's see how we can apply it, and let's take a look at what that means. Okay, so over here in this example, we have 5 passes, 1, 2, 3, 4, 5. So what we left is 5 numbers: 7, 13, 59, 31, and 19. And each of them has a remainder that we need to have, which is 7, remainder of 0, remainder of 1, 59, remainder of a 4. Wait, let me think. Remainder of 4. No, not really. So 1 minute after. It's the remainder of 12, right? I think minute is like the 59 minus that time that we need is the remainder that the last previous pass. So this is 55. And this is the let's see, this is 6 minutes, so 6 which is the remainder of 25, and this is 19, which is 7 minutes, which is remainder of 12, right? So based on the Chinese remainder theorem, what we need is we need to find a number x that satisfies all this criteria. And to do that, actually, the number is, we're going to think in terms of like the 7, the 13, 59, 31, and 19 over here. Okay. And so we have 5 components, right? And why 5 components is that we can make sure that this component is a multiple of all this. Then we just focus on the set, whether it is also a multiple of 7 with a remainder of 0, right? In this case, this component will be a multiplication of all this. Okay, and then the second component is the 13, right? This will be, make sure that it is a multiple of all this, such that we can only focus on 13, because we can just focus on the remainder of 13, because that multiple itself is what do I say, when you divide by any of it, will be disappear, right? So it's a 7 times 59 times 31 times 19, and then same thing goes here, is 7 times 13 times 59 times 19 for here as well. 7 times 13 times 59 times 31, and over here, so this thing itself is multiple, has to be a remainder of 0 when divided by 7, right? So let's see, actually, I think times 7 will make it that way, right? And over here, we need to make it a multiple, a remainder of 12 when multiply by 13, divide by 13, right? So it's like times something, some number. This is as true as well, right? So this number is, we need to find a number that is remainder of 55 and divide by 59. And finding all these numbers, so we can loop 1, 2, 3, 4, 5 to find this number. And once we find that, we just add all this number up. According to Chinese remainder theorem, this should work. Yeah, and that will be the x that we're looking for. So probably we'll try to code this out. Try it with these inputs, and then we shall see whether my understanding of that Chinese remainder theorem is correct. So what I'm going to do here is I'm going to replace this instead. Okay. Probably going to back this up somewhere over here. Okay. So, okay, we're going to save this file. And let's try and write the code. So, earliest arrival, we still do it, but we're not going to use it anymore. Bus timings, okay. We're going to filter. Not really filter, but we're going to for each, because we need to know the index of the number. So, timing, bus timing, as well as the index. And we're gonna have about requirements. Okay. Now push into these requirements. Push the index. Or how about we just call it index, and the index as well as the bus timing, right? I think there is a remainder that probably you can count it as well. The remainder is actually bus timing. Let me think. So bus timing is 7. Index is 0. Oh, so remaining is bus timing minus index. Okay. So once we have it, let us comment all this out. Once we have the requirements, so we don't even need to assign this anymore. Once we have requirements, what we need to do next is that we need to find, so for each number, we need to find, so first thing is we're going to look through. Okay, let sum equals to 0. So I'm going to call this as a sum of all this different kind of multiplication. Sorry, something hangs. Oh, okay, I think I pressed the wrong key. Okay, cancel. So sum is 0, and then for let I equals 0, I less than requirements dot length. Okay, first thing I need to get the product, which is product of all the other variables. Oh yeah, I think one thing I missed out when explaining about this is that it requires that all these numbers to be prime number or accrue prime to each other. In fact, it is 7, 13, 59, 51, 19 is prime. And even with this example, I looked through 17, 37, 43, 439, 29, 13, and all so forth. They're all prime numbers, conveniently for this question. So we found a product. So okay, I have to loop through everything again. And okay, increment. I think I forgot to increment over here as well. And we increment it if I is not equals j. We're not gonna have that. Okay, so if I is not equals j, product times requirement j bus timing, right? Times equals to, okay. And then we are actually going to find while product the remainder of the requirements bus timing not equals to, okay, so we need to okay, we need to keep adding something while product. Okay, so we keep finding the number that we need to times, right? Product times some number, some multiple. So we're gonna find this variable that we can times to find it. So we're gonna loop it through from, okay, so I'm gonna call this a equals to 1 and times a requirements bus timing. So when it, okay, so probably add this. This modulo this is not equals to requirements dot bus. So this should be the index, and we should get bus timing. It's not equals to requirements dot this is the bus timing. Okay, requirements dot remainder, then a plus plus. Find this number of a. Once we found it, then product equals to product times a with a sum plus the product. And I'm gonna find this number sum. Okay, let's try. Hopefully this works. Hopefully my understanding of Chinese remainder theorem works. Wow, doesn't look good to me. Probably something went wrong with the code. Let's take a look. Okay, so console log product. Oh, this is not a number, then this is wrong. The first fold. Bus timing. Damn. Okay, this. Okay, bus timing has to be a number. Okay, let's try again. No. Hold on. Okay, let's start from the beginning. I know why. I forgot to filter out x. If bus timing is not x. Okay. The first number. Apparently it took a while. So probably something wrong over here. Let's take a look. Okay, so the console product and requirements the remainder. Remainder is 7. Oh wait, you can't ever get remainder of 7, so probably this with modulo again with the bus timing. Yep, that's about right. Let's do that again. Oh, okay, we found a number. That's surprisingly fast. Let's look at it, whether it's correct, as in whether it fulfills. Not quite. 105555804. Oh, this number is too big. Where is it? 1068781. This number is so big. Let me think. I need to brush up with my Chinese remainder theorem. Something is not quite right over here. Okay, so just make sure that the numbers that we're looking at is not wrong. So 12, 55, 25, 12. It looks alright to me. See, 12. So x is this value. Okay, so I think first thing is to verify whether this number fulfills all the criteria. So note this. At least hopefully I get that understanding of. Okay. Divide by 13. Okay. And then 59. 31. 19. Okay, so I get the. So this number does fulfill all the requirements except that it's a bit too big. Right. So let's see. What could be go wrong over here? Okay, so I studied a bit more about the Chinese remainder theorem, and I realized that we are actually very close to the answer. So this number fulfills all this requirement, and it's a remainder. It has a certain remainder that is is multiplier of all the multiplication of this. So 7 times 13 times 59 times 31 times 19 is a much smaller number than this. So this minus this over and over probably will get our answer. So we just keep doing this until we reach a small enough number. So okay, 1068781, which is the answer, right? So yeah, it's just one more small step that probably we need to do. Is that when we reach here, then the next thing that we need to do is that a product of all. So it's a common multiple. It was 1 for let cons bus timing of requirements, common multiple times bus timing, and while the sum minus common multiple is greater than 0, then we just keep minusing off. Right, and then let's see. This is the number we're getting, and it's the answer. So let's remove all this, and let's take back our input and the moment of truth. Well, I'm gonna paste this in, gonna run this code, and it takes a while. Not sure whether it's doing well or not. My god, no, please work for me. Okay, so probably I'm gonna cut it over here now, and inspect again what's going on wrong over here. So I have this console back again. I'll make sure that at least it goes through. Okay, minus 4. Yeah, this is wrong. This is okay. So yeah. Okay, so probably I'm gonna have a function called okay, no. Okay, so I'm gonna remainder needs to be this value, and it needs to be if remainder is less than 0, we're gonna add back. Right, so this means is that we'll make sure that remainder stays within a range of 0 to the pass timing minus 1. Right, so if it's greater than that, we modulus it. If it's less than, and then once we have it, it's actually in a range of negative pass timing to pass timing minus 1. So we plus pass timing so that we wrap it to only one range. So let's try. Answer. This looks promising. And we're gonna paste it in. This is finally got this answer correct, and that's it.